The year was 1945. After 2 relentless years of research, the United States accomplished the unimaginable, a weapon of such destructive power that it would alter the course of history forever. It was a project cloaked in absolute secrecy, known only to a select few, with a staggering cost of $2 billion, equivalent to nearly $30 billion today. This weapon, called Little Boy, was dropped on Hiroshima, marking the first time a nuclear weapon was ever used in history. This was the size of the mushroom cloud that rose into the sky after the first atomic bomb detonation. For reference, that small figure you see there is a human. But how did we get here? How did scientists, under the leadership of Dr. Robert Oppenheimer, take what was once considered mere fairy dust, a theoretical concept, and turn it into one of the most destructive weapons known to man? Also, when the government invests $2 billion into a single project, there's no room for failure. The stakes were impossibly high. These scientists had to make sure the bomb would not just work, but work without a hitch. No last-minute failures, no underwhelming detonations. So how did they do it? Before we dive into the engineering marvel of the atomic bomb, let's first understand the science that made it possible. Uranium-based nuclear bombs operate on the principle of nuclear fission. Elements beyond lead on the periodic table are inherently unstable. Their nuclei break down, forming atoms of different elements and releasing a tremendous amount of energy in the process. In the case of uranium-235, when a neutron strikes its nucleus, it decays, forming barium and krypton and releasing 3 more neutrons. These neutrons then collide with other uranium atoms, triggering a chain reaction that grows exponentially. In a matter of microseconds, this reaction releases an enormous amount of energy, resulting in the devastating power of a nuclear explosion. The scientists at Los Alamos had a clear objective: to maximize the explosion radius for maximum destruction. Achieving this required pinpoint precision in the timing of the detonation. To accomplish this, the bomb was designed to detonate at around 600 meters above the ground. This altitude was crucial. It ensured that the explosion would spread over the widest possible area, maximizing its devastating effect. Now let's dive into the inner workings of the bomb. It contained 38.5 kilograms of enriched uranium in the form of projectile rings and 25.6 kilograms of enriched uranium as the target. To activate the bomb, these two masses had to be combined to create a supercritical mass of uranium. To understand supercritical mass, imagine 3 different spheres of uranium. The first, weighing less than 52 kilograms, is subcritical. When bombarded with neutrons, it releases more neutrons, but most escape, so no chain reaction occurs. The second, at exactly 52 kilograms, is the critical mass, where neutrons sustain a chain reaction at a steady rate, but still not enough to cause a nuclear explosion. The third sphere, with more than 52 kilograms, is supercritical. Here, the majority of neutrons stay within the sphere, causing the reaction to grow exponentially. By combining the uranium projectile rings and the target rings, the bomb exceeded the critical mass threshold, creating a supercritical mass capable of sustaining a chain reaction. Conventional explosives were used to achieve this combination. These explosives fired the projectile rings down a barrel at 300 meters per second. This high speed was crucial, and we'll discuss why in just a moment. Once the supercritical mass was achieved, a neutron initiator inside the bomb released a burst of neutrons into the supercritical mass, sparking the chain reaction that would lead to the devastating explosion. To ensure the success of the explosion, the projectile target rings needed to be fired at a speed of 300 meters per second. Any slower, and there was a risk that the chain reaction could begin before the rings were fully aligned and inserted. This misalignment could cause the entire bomb setup to blow apart prematurely, resulting in an underwhelming explosion. When a bomb fails to reach its full explosive potential due to a premature reaction, it's referred to as a fizzle. This is how the world's first atomic bomb, Little Boy, operated, marking the beginning of the nuclear era and changing the course of history forever.